I am Dr. R. Abdul Wahid, Assistant Professor of Chemistry, Jamal Mohammed College. Today I am going to talk about the lattice energy. This part is from the inorganic chemistry covalent bonding units. What is called lattice energy? The energy is released when oppositely charged gaseous ion come close together from infinite distance to form 1 mole of a solid ionic crystal is called lattice energy of an ionic compound. Metal in the form of gaseous state is reacted with the halides in the form of gaseous state to form the ionic crystal. With the removal of some amount of energy, that energy is called lattice energy. It may also be defined as the energy required to separate the oppositely charged ions to infinite distance from 1 mole of a solid ionic crystal. Ionic crystal is split into two oppositely charged ions. Here the energy is needed. That energy is called the lattice energy. I will give the example, you can easily understand. Energy released when an ionic compound is formed from individual atoms in the gaseous state. Sodium in the form of gaseous state, chloride in the form of gaseous state to form the ionic crystal with removal of some amount of energy. That energy is called lattice energy. It is also called heat of formation. It is expressed as delta H, heat of formation. The value is negative. This process is also called as exothermic process. Energy required to completely separate a mole of a solid in solid ionic compounds into gaseous ions. Ionic crystal separate into two ions. Here the energy is required. That energy is called lattice energy. The delta H value is positive. This type of process also known as endothermic process. The lattice energy is the force operating between two oppositely charged ions. Greater the lattice energy, stronger will be the ionic bond. Lattice energy is directly proportional to the product of the charges on the ions and inversely proportional to the interionic distance. The equation is given below. U0 is directly proportional to the Z plus Z minus by R, where R is interionic distance, Z plus is charge on the cation, Z minus is charge on the anion. Sometimes R is referred to as radius of the cation and radius of the anions. What are the factors are affecting the lattice energy? Ionic charge. Lattice energy is directly proportional to the product of the charges on the ions. Higher the lattice energy, charge will be the higher. Lattice energy is decreases, charge will be the decreases. The lattice energy of ionic solids with multiply charged ions is greater than those with singly charged ions. The table shows ionic crystal and lattice energy. Lithium fluoride, it shows 1004. This is the lattice energy value. Calcium fluoride 2644. Calcium oxide is 3520. Compare these three. Lithium plus F minus charge, calcium 2 plus, fluoride minus charge, calcium 2 plus and oxygen 2 minus. Here calcium oxide is more charges, so it shows the higher lattice energy. Second one is interionic distance. Lattice energy is inversely proportional to the interionic distance between the ions. For example, you can see the table: lithium fluoride, sodium fluoride, potassium fluoride, rubidium fluoride, cesium fluoride. Lithium fluoride, here cations are different, anions are same. Compared to lithium to cesium, lithium is smaller size radius of the cation. Cesium is larger radius of the cation. You can see the periodic table. In the periodic table, left to right, the atomic size is decreases. Top to bottom, the atomic size is increases. You can see the order of the stability. Lithium fluoride is high than sodium fluoride, then potassium fluoride, then rubidium fluoride, then cesium fluoride. Similarly, since the size of the halide ions increases from fluoride to iodide, you can see the table: lithium fluoride, lithium chloride, lithium bromide, lithium iodide. Lithium cations are same, anions are different. The previous slides I said the radius of the anion is small, higher is the lattice energy. The radius of the anion is large, lattice energy is low. So lithium compared to iodide, lithium is a small radius than only the iodide. What are the importance of lattice energy? Stability of ionic compounds. Lattice energy is measure of the stability on ionic crystal. It varies with the charges of the ions. Lattice energy is directly proportional to the charges on the ions. The order of stability: lithium fluoride, calcium fluoride, magnesium sulfide. Magnesium sulfide is higher lattice energy because charges are high. Mg2 plus S2 minus. Lithium, Li plus F minus. Calcium fluoride, calcium 2 plus F minus. So magnesium sulfide is higher the lattice energy because charge is high. Lattice energy is inversely proportional to the interionic distance. It will be discussed. It discussed the previous slides. Order of the stability: lithium to cesium. Lithium is high lattice energy because the radius of the cation is small. Solubility of ionic compounds. Ionic compounds with a high lattice energy are stable, in which low lattice energy are readily broken up into ions in polar solvents. Lattice energy is inversely proportional to the tendency of an ionic solid to dissolve. Which ionic solids are higher the lattice energy? Solubility is high, so low solubility, but more stable. Which ionic solids are low lattice energy? It readily soluble in solvents, so it is a less stability. For example, I will give the example: lead sulfate is sparingly soluble while sodium sulfate is highly soluble in water. The reason is that the lattice energy of lead sulfate is very high compared to sodium sulfate. Here charge, lead, lead is high charge compared to the sodium. Sodium is 2 plus, lead is 4 plus. So lead having the higher charge, so higher the lattice energy, it will be stable. But sodium is low lattice energy, easily soluble. Then Born-Haber cycle. The cycle is clearly pointed out how to calculate the lattice energy of every ionic compound. The cycle is based upon the fact that the formation of an ionic compounds may occur either by direct combination of the elements or by an alternative process, in which the first one, the reactants are vaporized to convert into gaseous state. Second one, the gaseous atoms are converted into ion. Third one, gaseous ions are combined to form ionic lattice molecule. For example, the formation of sodium chloride can be shown as This is the overall reaction. Here the removal of energy, that energy is lattice energy. The delta H value is negative, so heat of formation. The above reactions involve the following steps. Sodium in the form of metal, so in the form of gas, solid state, solid is converted into gaseous state. In this process is called as sublimation energy. Chlorine molecule is converted into chlorine atom. This process is also called as dissociation energy. Sodium in the form of gaseous state converted into sodium ion with removal of electron. It is called ionization energy. Chlorine, having the tendency, it is a more electronegative atom. It will pulls the electron towards itself. It attract the electrons. It will attain the chloride ion in the form of gaseous state. In this process is also known as electron affinity. So overall reaction is the formation of sodium chloride with the removal of energy. That energy is lattice energy. This is the presentation. Representation is clearly pointed out the how the metal is reacted with the halide to form the sodium chloride for the following steps. Applying the Hess law of heat of summation, we will get the final equation U0 is equal to E plus S plus half D plus I minus A. U means lattice energy, E means heat of formation, S means sublimation energy, D dissociation energy, I ionization energy, A electron affinity. Test yourself questions. Find the correct order of the lattice energy. I discussed the previous slides. Here you can see note only one point. Size and charge, two factors are more, which one is more dominant? Charge is more dominant than the size. Which ionic crystals are high charge, it will be more lattice energy. Thank you.